Okay, guys, chapter P, section 2, we're continuing. We're still talking about exponents. The first day we talked about exponents, and it was just nice, pretty whole numbers, right? Then we talked about negative exponents. How do we make a positive exponent? How do we make a negative exponent positive? We move it. I like the word, we move. We don't flip, we move. If it's in the numerator, you move to the denominator. If it's in the denominator, you move to the numerator, right? So today we're going to talk about rational exponents. Anybody know what the grown-up word rational means in math? It's everyone's favorite thing to do in math. Fractions, right? We're going to talk later about adding and subtracting rationals. That's just adding and subtracting fractions. Just going to have letters in it, different stuff like that. But rational exponents means they're fractional. So what we're going to do is we're going to take our fractional exponents and we're going to convert it to roots because that's how our brain thinks a little better, and we're going to simplify, and you guys are going to be fine. So here we go. Anything that we have talked about so far, guys, will be applied to this lesson. If you have the same bases and you are multiplying those bases, what do we do to the exponents? Same bases, multiplying, what do we do? Add. All right? If we have the same base and we're dividing, what do we do? Subtract. If we have negative exponents, do we leave them as negative or we make them positive? We make them positive. We move stuff around. So all of that is going to be applied in what we're doing today. What is new, or what is new for us this year, maybe you guys have seen it before, is a fractional exponent. So what I want you to notice here is A is your base, and M over N is your fractional exponent. The denominator of the fraction becomes the index, becomes the root. And then the numerator is your exponent. Okay? I'm going to repeat that 15 times. But when you have a fractional exponent, notice that right here, this 2 out here on x to the 1/2 becomes the index. The 1 becomes the power. Do I have to write a 2 in front of the square root? No, it's just, it's understood that there's a 2 there. If I have x to the 1/3, if you notice, the 3 becomes the index, and then the 1 is the power. X to the 2/3, watch, the 3 becomes the index right here, and then the numerator, the 2, becomes the power. When you guys have this, and it's not just to the 1 over something, it's a 2/3, 3/3, whatever, 4/3, you're going to want to simplify the root first, then evaluate the power. You'll see what I mean by that in a second. Can it be done backwards? Yes. But without a calculator, you're going to really want to evaluate the root first, then square a number. You don't want to square a number, make it ginormous, and then say, well, what number times itself 3 times gives me that? You want to simplify the process as much as possible. So let's go through some examples. All right. When you guys are taking your quiz, I want to see your thought process. As you're showing work, you're gaining points. You guys might make a little mistake, God bless you, somewhere along the way. But if you're showing me your thought process and I can see that you understood part of it and then you just made a little mistake here, I can give you points for that. But if you just answer the question wrong and there's no work, no good. On every single test and quiz, it's no work, no credit. You've got to show your work. So in a case like this, and I told last period the same thing, every time I make answer keys, all the little things that I tell you guys to do, I still do to remind myself. I remind myself that the 2 is going to become the index. I always just draw an arrow to say, hey, remember that 2 goes out there. So what this is really saying is the square root of 4, which is, that was scary. Not a trick question. So I have 27 to the 2/3. Remind yourself, it's the 3 out here. This becomes the index. So this becomes the cube root of 27, and then I square. Do you see why I say it's easier to evaluate the root and then square? Does anybody in here want to multiply 27 times 27 and then figure out what number times itself 3 times gives you that? No, that's crazy. Evaluate the cube root. Cube root means what number times itself 3 times gives you 27? 3, good. So I have 3 squared, which is 9. All right, let's talk about showing work again. Say you do this. You show me that you understand 2/3 becomes the cube root of 27 squared. Then you write 3 squared. And then you say 3 squared is 6. Is 3 squared 6? No. Do I know everybody in here knows that 3 squared is not 6? Correct. But if you show me your thought process, you understand that a rational exponent has an index as the denominator, the numerator is the power, then you understand that the cube root of 27 is 3, and then you just make a silly mistake like that, that's a point or two off. Because you understood this whole concept in here, you just made a silly mistake there. So I cannot impress upon you enough the value and the importance of showing your work. All right, let's come to this question, number 3. What are we dealing with here? A negative exponent. We don't like negative exponents. We don't want to deal with them. So what's the first thing I need to do? Where does 81 to the negative 1/4 need to go? It's got to go down. It's got to go to the bottom. So this is actually 1 over 81 to the 1/4. Not sure why my 1 is so large. And that should be a 4, not a 2. All right, so now let's think about this. What does this 4 become? The root or the index. So this question is really asking 1 over the 4th root of 81. What does that mean? What number times itself 4 times gives me 81? Tell me. 1/3. Yep, 1/3. Good. If you guys tell me the answer here is 3, you really don't understand the concept of a negative exponent. In order to become positive, it needs to go to the denominator, so it's not the whole number 3. So just stuff like that, you guys got to pay attention to. All right. Any negative exponents or anything here? No, we're good. So 4 becomes my index. Remind yourself of that. So I have the 4th root of 16. I'm going to do that first. Then I'm going to cube that number. I'm not going to multiply 16 times itself 3 times and then try to figure out what number times itself 4 times gives me that ginormous number. That's just silly. Make your work smarter, not harder. What's the 4th root of 16? What number times itself 4 times gives me 16? 2. Perfect. And then 2 cubed is 8. Good job. Any questions so far? We're good? So far, so good? All right. Same thing, same thing. Evaluate first. What is going on? Do I have a negative exponent? Yes. I have to deal with that first. So what do? It's 1 over 1,000 to the 2/3. Perfect. All right. Now what? Where is that 3? The 3 becomes the what? The root. Good. So I have 1 over the cube root of 1,000 squared. Well, what number times itself 3 times gives me 1,000? 10. And then 10 squared is? So it's 1 over 100. Perfect. Good job. I'm going to skip 6 for a second. We're going to do 7. And we'll come back to 6 and 8 together. Negative 64 to the 2/3. Guys, am I dealing with a negative exponent? No, don't just put that 1 over and say, oh, now the 64 is positive. That doesn't work like that. You only move negative exponents. So this is actually the cube root of negative 64 squared. Can I take the cubed root of a negative number? What's a negative times a negative times a negative? A negative. Can I take the 5th root of a negative number? Yes. Can I take the 7th root of a negative number? Yes. Can I take the square root of a negative number? No. You can, but what's your answer? Is it real? No, it's imaginary. We'll talk about that in a minute. So what is the cube root of negative 64? What number times itself 3 times gives me negative 64? Negative 4, correct. And then negative 4 squared is 16. Good. Very good. Some of you will tell me, oh, it's 4, and 4 squared is 16. That's not right. Negative 4 is the cube root of negative 64. And then the answer is 16. So let's go back to 6 and 8. How are 6 and 8 different? The parentheses. Cannot impress upon you enough. You will see something like this on your quiz We're not trying to trick you. We're trying to make sure you're paying attention and that you are thinking, that you understand the concept. So what is 6 asking you? To do what?
Find like the exponent of like just a 0.
You're going to take the square root of what number and multiply it by what? Negative what? 1. Okay, this is saying, evaluate the exponent first. It's saying, here's my negative, and then I'm going to find the square root of 100. Because this 2 comes out in here. What is the square root of 100? 10. So my answer here is negative 10. Good. What is number 8 saying? The square root of negative 100. Which is, you could say no solution. You could say can't do. You can say imaginary. You can find the square root of negative 100, but it's imaginary. We're just dealing with real numbers now. Sure. The square root would actually be 10i. We'll talk about that later. Did you say yes? Okay, perfect. All right, a couple more of these, then we're going to go on to something else. Not a different concept, just a little more in-depth problems. This 3, remember, is going to become your index. So it's the cube root of 27 to the 4th power. What number times itself 3 times gives me 27? 3. Then I have 3 to the 4th power, which is perfect. You guys are going to see the numbers, your bases, your roots. When you take the cube root of a number, you're not going to get much bigger than maybe 6. Because when you think about it, if I give you a number that you're trying to find the cube root or the of 5,723, that would take you a long time. And that's not really what we're testing you on, is can you find ridiculous roots. All right, this is why I think it's so important, so very important for you guys to draw the arrow. Because think about this. What is this question saying? Square root of 64 to the 3rd power, right? What's the square root of 64? 8, and then 8 cubed. Well, 8 times 8 is 64 times 8. It is 512. Some of you are like, whoop, got that in my head. Some of you are like, how do you do that? Watch how you do it. You go 64 times 8, and you go back to single-digit multiplication, and you guys work it out. But why do I think it's important for you guys to do the arrow? Because a very common mistake on a problem like this is you say, what's the cube root of 64? And then I square it. Is there a cube root of 64? What number times itself 3 times gives you 64? 4, right? And then 4 squared is 16. Is that the actual answer to this problem? No, that would be 64 to the 2/3. So sometimes you'll say, oh, well, obviously this won't work because there is no, square root of 17 or something. But sometimes if you flip it, you're not paying attention, you will think that it works out and it's fine. So don't make that mistake. Take your time and say, okay, what is this question asking? What am I doing? Where do I start? That's the biggest thing I can caution you guys. What do you notice here? Number 11. There is a parenthesis. Good. And then what else do you notice? There's a negative exponent. So let's deal with that first. How do I make that positive? I'm going to move it down. So it's 1 over. Does 32 become positive? No, the number still is negative, and that's fine. So now I'm going to go, okay, well, how do I simplify this? My 5 is going to become my root. So it's 1 over the 5th root of negative 32 to the 4th power. What number times itself 5 times gives me negative 32? 2. What kind of 2? Negative 2, and I'm raising that to the 4th power. So my answer is, what is it? 1 over 16. Good. All right, now we're going to get a few harder ones. Get progressively harder, and then we're done. And I'll answer questions on homework, if you guys have any. I see a negative exponent, so we're going to have to deal with that. But what else do I also have to deal with? It's a fraction. I have to distribute, don't I? So this negative 3 over 2 is going to go here and here. So I'm going to say 121, whoops, forgot the 1. 121 to the negative 3 over 2. and then 100 to the negative 3 over 2. Okay, how do I fix this? What do I do? There's so much about that. Talk to me. What do I do?
You move you swap.
God bless. I'm going to swap it. I'm going to move them. I'm going to move this up and this down so my exponents become positive. So 100 to the 3 over 2, and then 121 to the 3 over 2. So now we're just going to evaluate each independently. Remember, your denominator becomes, excuse me, the index. Your denominator becomes the index. So this is the square root of 100 cubed over the square root of 121 cubed. What's the square root of 100? 10. What's the square root of 121? 11. 10 cubed is 1,000. What's 11 cubed? Yep, 1331. How we feeling? Not bad-ish. Some of you are like, it's a lot. All right, here we go. Now, there are several ways to solve and simplify these problems, okay? I'm not telling you that there's only one specific way that you can do it. But I want you to understand, you guys have got to think through. Some of you guys are going to get your first quiz and just freak out. You're going to look and be like, I don't remember anything. We can't do that, right? We've got to take a deep breath and figure out what's going on. Some of you, your first thing you do here is say, okay, this goes here and this goes here. So you have the cube root, don't write this down, of 6 to the 4th. Sorry, the cube root of, 6 to the 4th. And then you're going to say the cube root of 6 squared. And then you're going to go, this problem doesn't work. There is no cube root or square root of 6, right? So say you do that. You need to take a breath and go, wait a second. I'm sure I'm missing something. What can I do? If this doesn't work, you're like, wait a minute. What can I do? Why am I adding the exponents? You're right. Because the bases are the same. We're multiplying bases that are the same. Fantastic. So what do? We rewrite the base and do what? You add the exponents. Are you allowed to add fractions? You sure are. So exciting. What's 4/3 plus 2/3? So 6 to the 6/3. Now you're like, what? 6/3. Guys, what's 6/3? It's just 2. So this is really 6 squared, which is 36. Good. We don't freak out. The time for questions is not on the quiz. I will not be answering questions during the quiz. So you got to make sure you know what's going on. All right, there's 2 ways to look at this one. There's 2 ways to look at this one. What jumps out at you? It's a fraction. Okay, are there any negative exponents? No. Chase, what are you thinking?
It's the same base.
Same base. So what do? We're going to rewrite the base and do what to the exponents? Subtract. So 7/3 minus 5/3 gives me 125 to the what? 2/3. Okay, so 3 becomes my index. I have the cube root of 125 squared. What's the cube root of 125? 5, and 5 squared is? Perfect. All right, anybody else see that a different way? Everyone saw that exactly the same way? I find that hard to believe. Last period, someone said, well, can't you simplify the numerator and the denominator? Can we? Okay, let's try that. If I take the cube root of 125, what is it? 5. So 5 to the 7th over the cube root of 125 is 5 to the 5th power, right? All right, well, what do we notice? Bases are the same, so 7 minus 5 is 5 squared, which is what? 25. Is that the same thing we came out with? Yeah. So if Luke did it the way I did in red and Chase did it the way I did in green and they showed their work, are they both right? Yes. If mathematically it makes sense and you're following the correct processes, not that just we happened to get the same answer because we made a mistake along the way and it worked out, because sometimes that does happen. You guys as long as you're showing your work, it's fine. All right, same base, multiplying, what do? Add. So I write a big R, we rewrite the base, and I have negative 8/9 plus 17/9 gives me R to the what? Yep, 9 over 9, which is r to the first power. Is it wrong if I write the 1? No. Is it okay if I don't? Sure. You don't have to write 1 as a coefficient. You don't have to write 1 as an exponent. But if you do, not a big deal. If it helps you, if it makes you feel better, do it. All right, moving along to the fun ones. All right, these are the types that you guys are going to see on a quiz. All right, don't freak out. Work through this. There's 2 ways I see the way that my brain works. What do you guys see? What would you do first? Tell me. Say it again. Okay, common base. So you would multiply, since the bottom has the same base, right? You're multiplying same base, you do what to the exponents? If we're multiplying same base, we're going to add, right? And then you can subtract. Perfect. Anybody else see something else that they would attack it? The negatives. That's the first thing I saw. I was like, ooh, I don't like it. So what can I do? I can move the z to the negative 2 up here, right? So I have z to the 3/4 times z to the 2 second. Oh, I should make it look like a 2. To the second over z to the 5/4. Make sure your numerator is simplified and your denominator is simplified, and then you can worry about simplifying numerator over denominator. But in the numerator, if I have the same base, what do? And I'm multiplying. We rewrite the base, correct? And do what to the exponents? Add them. Can you add 3/4 and 2? Yeah, some of you are going to be like, oh, it's to the 2 and 3/4. We don't write exponents like that. You don't have exponents as mixed numbers. So how do I add 3/4 and 2 over 1? What do you need? A common denominator. What's a common denominator between 4 and 1? 4. If I multiply the bottom by 4, I have to multiply the top by 4. So what's 3 plus 8? 11 over 4. Perfect. And then I have this. All right, now what do? Same base. So we rewrite the base and do what to the exponents? Subtract. What's 11/4 minus 5/4? 6/4. You get this far. It's a 10-point question. You have earned 8 or 9 out of the 10. What are we missing? Simplify. What's 6/4 the same as? 3 over 2. If you wanted to write it like this, you could. That's the same thing, but you don't have to. This is perfectly acceptable. You can leave fractional exponents on variables as long as they're positive. That's fine. Now, again, when we started this problem, some of you might have said, wait a second, can't I just say z to the 5/4 times z to the negative 2, and since we're multiplying, say z, add the exponents, right? What's 5/4 plus a negative, that remember this was 8/4, right? What would that give you? What is it? Yep, negative 3/4, so you just go from there. So this would be negative 3/4. So you would have had z to the 3/4 over z to the negative 3/4. Do those two things cancel out? Yes or no? Do they cancel out? Not a trick question.
Yes.
Well, what's the rule? You subtract exponents. So it would be z to the 3/4 minus a negative 3/4. What's minus a negative? You add them. This would give you 6/4, which is the same answer we got over there, isn't it? Or you could say, wait a second, there's a negative exponent. I got to move it up here. Then it would become positive, and then you'd add them together. That's why this right here is the reason I say deal with the negative exponents first. Because some of you would have gotten that wrong. You said, oh, 3/4 negative, they cancel out. That's not the case. Remember, if you have a negative exponent, you got to move it. Either move it up or move it down. 17. You guys are like, Lord help me. No, you're not. Look at what's going on. The first thing you should deal with is what? Distribute what? The 15. Totally agree. 15's going here. 15's going here. Last period, someone asked a very good question. They said, how come you didn't distribute it to the bottom? Because the parenthesis, the only thing that's getting a hug is the numerator, right? Not the whole thing. So let's go ahead and simplify this. I have x to the 15 fifths times y to the 30 thirds over x squared. You guys are like, seriously? What's wrong with you, Mrs. Meadows? This is not a hard problem, guys. What's 15 divided by 5? Oh, wow. Good job. What's 30 divided by 3? Oh, my goodness. Now what? Subtract what? The x. So 3 minus 2. Come on, come on. 3 minus 2. Perfect. Was that really that hard of a problem? No. Just because it looks a little intimidating at the beginning, guys, you guys know how to do this. Think about everything that I've said when we go. If you have a parenthesis and an exponent outside that parenthesis, distribute first. Some of the questions that you get are going to look like a big mess, and you just have to simplify. You just got to take your time. What do I do here? Any negative exponents that I need to deal with? No. Okay, that's good. That's real good. So what do I do? Yeah, distribute. Power to a power. What do I do? Multiply. So I have p to the what? 3/4. Perfect. And again, on your test or quiz, if you don't like any other letter but x and y, change them all to x and y's. That's totally fine. What do I do down here? I multiply, so I get p to the what? 10 over 4. Now some of you are going to say, oh, I can simplify that. Should I? Why not? It's the same base. It's the same. So don't make anything harder. Yes, that is 5 over 2. And if you recognize that, fantastic. But since you have a base on the top and a base on the bottom that are exactly the same, what are we going to do to the exponents? We're going to subtract. So I'm going to rewrite my base and say top minus the bottom. And I come out with what? P to the negative 7 over 4. And we don't like negativity in this class. So how am I going to simplify that a little bit more? We're going to move it down. Good. It's 1 over p to the 7/4. And that, ladies and gents, concludes our Friday.
Can you just scroll?
Sure.